Hello everyone, welcome to my YouTube channel AV Classes. So our next topic in ray optics is the refraction through rectangular glass slab. So consider this a rectangular glass slab of thickness T, and let's suppose a ray of light incident on the first interface, that is the air and the glass. So this is the first interface and this is the second interface. Okay, so as light travel from a rarer medium to a denser medium, the refracted ray bends toward normal. Now as the light further propagate and as it faces the second interface, now this time this is a denser medium and this is the rarer medium. So the light has to travel from a denser medium to the rarer medium. So the light get refracted away from the normal. Okay. Now apply the Snell's law here. So this is the air, this is the glass. Okay. And this is the angle of incidence, angle of refraction, angle of incidence, angle of refraction. So for first interface, A mu g is equal to what? Sine I1 upon sine R1. Okay. And G mu A is what? See, पहले यहाँ पे एयर से ग्लास में जा रहा है इसलिए हम ये इंटरफेस यूज करेंगे, हमने लास्ट लेक्चर में मैंने बताया था ए म्यू सी. नाउ अब ग्लास से एयर में जा रहा है तो जी म्यू ए करेंगे, विच इज इक्वल टू व्हाट? साइन I2 अपॉन साइन R2. ओके. एक रिलेशन मैंने लास्ट लेक्चर में बताया था, वो ये था कि ए म्यू जी इज इक्वल टू 1 अपॉन जी म्यू ए. ओके. So as you multiply both, you will get 1. So this implies what? You have to multiply both. What does it mean? It means this G mu A is equal to 1. So put the value here. You have the value. So this is equal to sine I1 upon sine R1 into sine I2 upon sine R2 is equal to 1. Now see, this is a rectangular glass slab. So this interface and this interface are parallel and this act as a transverse line. So this angle R1 is equal to I2. Why? Alternate angle. So if R1 equal to I2, then this will cancel out. Why? Because I2 is equal to R1. Then sine I1 is equal to sine R2. This implies I1 is equal to R2. What does it means? That this value I1 angle R2 are equal. It means that if you extend this ray, then this ray and this ray are parallel. Why? Because of this exterior corresponding angle are equal. Okay. So as you see, initially this light has to face the first interface, get refracted, again it face second interface and get refracted. So the ray which get out of this rectangular slab after the second interface is called emergent ray. Emergent ray. And you see, this emergent ray is not lie along the line of this incident ray. See, this incident ray is here and this emergent ray is here. So you see, there is a lateral displacement takes place here. This is called lateral displacement. Lateral displacement. Okay. See, the original incident ray and emergent ray not lying on the same line. The emergent ray get displaced from its original ray by some amount, which is called lateral displacement. So our aim is to find the value of this lateral displacement. As we know, this angle I1 is equal to R2 and this angle are equal. Okay. Then So what we will do, let's say this angle is I, this angle is R, okay, and this R is same as this R, and this I is same as this I, okay. Now see, just this is the perpendicular distance between these two rays, so drop a perpendicular here from this point on this line. Let's say this is X. Now extend this normal here. So this T is equal to this T. This is R. So what is the value of naming it? A, B, C, okay, D. So AB is T, angle BAC is R. So what is the value of AC? AC is what? See, cos R is what? AB upon AC. AB is what? T upon AC. So AC will be equal to what? T upon cos R. Okay. Now we got this value AC. Now what is the angle of this? This is equal to I minus R. Why? Because whole angle is I and these are vertically opposite angle and R is this value. So this value is what? I minus R. Now this is perpendicular, this is X. So apply in triangle ACD. In triangle ACD, sine I minus R is what? Perpendicular upon hypotenuse. Perpendicular is what? X. Hypotenuse is what? AC. This implies X is what? AC multiply हो जाएगा इधर. AC की वैल्यू कितनी है? T. T upon cos R sin I minus R. Okay. So the X will be equal to T upon cos R expanded sin A minus B. So sin A cos B minus cos A sin B R. Take this denominator into the bracket. So X is equal to what? T sin I minus cos I sin R upon cos R. Now what we will have to do, see, out of this angles, which angle, आपको क्या लगता है कि कौन सा एंगल हमारे कंट्रोल में है? क्या आई को हम एक्चुअली देख के पता कर सकते हैं ना, लाइट कितने पे इंसिडेंट कर रही है? ये तो हमारे हाथ में है. कितना रिफ्रैक्ट होगा, कितना इमर्जेंट होगा, वो तो हमें पता है नहीं. तो हम क्या करेंगे, इसमें जो भी आर का टर्म है कॉस आर का, उसको आई में कन्वर्ट करने की कोशिश करेंगे. उसके लिए हम स्नेल्स लॉ यूज करेंगे. नाउ म्यू इज व्हाट? साइन आई अपॉन साइन आर. दिस इंप्लाइज साइन आर की वैल्यू हमें चाहिए. साइन आर की वैल्यू कितनी हो जाएगी? साइन आर इज इक्वल टू साइन आई अपॉन म्यू. ओके, एंड कॉस आर इज व्हाट? Cos r is what? Under root 1 minus sin square r, which is equal to under root 1 minus sin square I upon. Okay, put this value cos r and sin r in this equation. So what will we get? See, x is equal to t sin I minus cos I sin r. Sin r is what? Sin I upon mu, and cos r is what? This value 1 minus sin square I upon mu square power 1 by 2. So x is equal to t sin I minus cos I sin I. Now this mu is getting up in numerator, so we will get mu, and mu is cancel out. So what we will left? This is equal to mu square minus sin square I power 1 by 2. So x is equal to t sin I common 1 minus cos I upon म्यू स्क्वायर माइनस साइन स्क्वायर आई पावर 1/2. So this is the lateral value of lateral displacement by which the emergent ray get displaced from the original incident ray. Okay, these are the expression in term of I. Why we find this expression in term of I? Because I हमें पता है कि किस एंगल पे हमें लाइट को एक्सपोज करना है उस रेक्टेंगुलर सरफेस पे. That's why we have to take this expression in terms of I. So these are the things we are discussed in this lecture. Now in next lecture we are talking about the total internal reflection. So अगर वीडियो पसंद आ रही है तो पूरा देखा करिए प्लीज, और लाइक और कमेंट जरूर करिए. थैंक यू.